In this video, we're going to talk about compound inequalities. It's the idea that you can take more than one inequality at the same time and look at it. So maybe you're looking at points in both inequalities together, or points or numbers that satisfy one inequality or the other, just depending upon the situation. So there's two things that we're going to be considering. One is called an intersection, and one is called a union. Okay, so let's take a look at those two ideas. First of all, an intersection. So the intersection of any two sets in general is all of the points that are contained in both of those sets. Okay, so the intersection is all elements of both sets. Okay, so just kind of a general definition. So for instance, if you were to have two different sets, let's say you had the set, we'll call it set A, is the set containing all of the even integers. Okay, just as an example, all even integers, so like -4, -2, 0, 2, 4, and so on, right? All of the even integers, 2, 4, 6, 8, and so forth in the positive, -2, -4, -6, so forth in the negative, and 0 in the middle. Those are all the even integers. And then let's say you wanted a set that has just the integers 0 through 9, all right? Or just so that's the second set. It's just 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, the intersection of these two sets are going to be all the numbers that appear in both of them. Okay? So the intersection is labeled with this sort of upside down U sort of shape, kind of like a rainbow. All right, so that's the intersection symbol, and A intersect B is all of the numbers that are in both sets, right? Both sets. So, well, the number 0 is in both, 2 is in both, 4 is in both, 6 and 8 would also be in both, okay? So the intersection would be 0, 2, 4, 6, 8. And that's it, right? None of the other numbers in this set B are in both, because on top we have just the evens. And none of the other numbers, none of the negatives and none of the numbers larger than 8 are going to be in the intersection, because they are not in set B. Okay, so we're looking at only numbers that are in both sets. Now with sets, that's fine, but let's look at intervals. Intervals are not individual numbers, but there's just large continuous sets of numbers. So let's say we had two intervals. We'll say interval A is the interval from -3 to 7, and interval B is the interval from 0 to 9, and that one I'll include the endpoints. So the first one I didn't include the endpoints, the next one I did. And what I want to do is look at the intersection of those. All right, so I'm looking at trying to figure out what A intersect B is. Well, an intersection, one thing I can do is look at a number line and figure out what numbers are in both intervals. Okay, it has to be in both. And so this first interval runs from -3 to 7, not including the ends. Right, so I put parentheses on it. The second one runs from 0 is a little bit, 0 is kind of in between those two, up to 9, which is over toward the right there. And it does include both of the endpoints, so I shade those in, or put brackets on them. Well, the intersection then is all the points that are in both. Well, between -3 and 0, those numbers are only in the first one, not the second. Between 7 and 9, those are in the second but not the first. And so the only things that are in both would be everything from 0 to 7, right? 0 to 7 are going to be in both, like things like 1 and 2 and 3.6. Those are in both. Okay, so from 0 to 7, we have an intersection, everything in between. But then the question remains, what about the endpoints? And so 0 is definitely in the second one because I have it included. It's also in the first one because it's between -3 and 7. Okay, so 0 is in both, and so I want to include it in the intersection. 7, however, is in the second one. It is shaded in, but not in the first one. It was not included, and I had a parenthesis there. So it is not in the intersection because it's only in one and not the other of the original two intervals. Okay, so the intersection is the interval from 0 to 7, including the 0, but excluding the 7. Okay, so just an example. I want you to see kind of how that works out where you're looking at values that are in both sets. Okay. Typically, we will use, if we're writing this out in English, we would use the word "and" to represent an intersection. So let's say I want numbers that are in set A and set B. Okay, so the word "and" typically represents an intersection. All right, A and B, for instance. All right. Now you could solve inequalities in a similar way. I could say I want to solve the inequality, it's a compound inequality where x plus 8 is less than or equal to 4 and 2x minus 1 is greater than 19. Okay, so this is what we call a compound inequality. It uses the word "and." It's going to end up being two different intervals, and we're going to find the intersection or the overlap between them. Okay, so this first one, if I subtract the 8, I get x is less than or equal to -4. Okay. In the second one here, I need to add 1 to both sides. I get 2x is greater than, what's that, 20? And if I divide both sides by 2, I get x is greater than 10. So now I have two intervals, and I want to find all numbers that are in both. Okay, so here, this first one, well, let's write it out in a single number line. We've got -4 as one of the endpoints and 10 as the other. In the first inequality, I want all the numbers that are less than -4. Less than or equal to. So that would start at -4 here and go to the left. I'm going to do the shading kind of above, and then we'll do the overlap on the axis there, or on the number line. X greater than 10 is going to be all numbers starting at 10 and going to the right, not including the 10. So now the question is, where's the overlap? Well, in this one, there is no overlap. There's no points that satisfy both of those inequalities, or both of those intervals. And so here, the intersection is the empty set. There is no solution. Okay, so I would write no solution and put in as the intersection simply the empty set. There is nothing there. Okay, and that can happen. You might see some of these in the homework or on a test. Some of them will have solutions. You may even have some examples where the entire number line is the intersection in which you have all real numbers, okay, as a solution. So really a variety of possibilities. Let's look at another example. Let's try this one. A lot going on here. So again, this is an AND problem. We're going to solve each of these inequalities and then look at the overlap of their intervals. So this one here, I'm going to add the 8 to both sides. I get 5x is greater than or equal to, what's that, negative 25. Divide both sides by 5. X is greater than or equal to negative 5. Everything's solved out very nicely. We did not have to interchange the inequality symbol at all. On the second one, I need to add 7 to both sides. I get negative x is greater than negative 3. And then I have to divide out the negative 1, which, remember, switches the inequality symbol. And you divide both sides by a negative. And so I'm left with x is less than 3. Now if I look at the overlap here, look at the number line, we've got negative 5 and positive 3. I'm just going to real quickly, I'm going to sketch each of these, but again above the number line, and then we'll look at the overlap on the number line. So if x is greater than or equal to negative 5, that's everything to the right of negative 5, okay? X is greater than or equal to, and it includes the negative 5, so I put a bracket there. If I look at x is less than 3, that's going to be everything to the left of 3, not including the 3, so I put a parenthesis there, okay? So now I want to look at the overlap. Well, the points that are on both of those intervals are the ones in between negative 5 and 3. Right, they're in between, so I shade all of those in. And then if I look at the endpoints, the number negative 5 is in both of them. It's in the first because the endpoint is included, and it's also in the second. So that one I'm going to put a bracket on. The 3, however, is in the first but not in the second, so I can't include that in the intersection. So it remains with a parenthesis. And so my final solution is going to be the interval negative 5 comma 3 with the negative 5 included and the 3 not included. Now if I wanted to write this as a solution set rather than an interval, I could do that. Let's say x is x such that, now the property that x has is that it is both greater than or equal to negative 5 and less than 3 at the same time. Now, rather than writing out those two inequalities separated, I could actually combine them into one inequality. To do that, I want to think about this in the opposite order. I would think about this as negative 5 is less than or equal to x. Excuse me, remember that when you switch the order of an inequality, you have to switch the inequality symbol. And then I would put these two together, saying that negative 5 is less than or equal to x, which is also x is less than 3. So I could combine it and say x is less than 3. Because it's an overlap, both of those inequalities occur at the same time. And so we can write what we call a 3-part inequality. It's a version of a compound inequality in which you actually have 3 parts to it. And the x is kind of in the middle between the left endpoint and the right endpoint. This only works for an intersection, okay? The 3-part inequality only works for an intersection because the x value must satisfy both inequalities together, okay? Must be both together.